Dear student, in this video lecture, we are going to discuss about a parallel plate capacitor. Dear student, capacitor is a device which is used to store electrical energy. Electrical energy is stored in a form of charge. So we can define capacitor as capacitor is a device which store electrical energy in a form of charge. Capacitor consists of two types, consists of two plates. Capacitor consists of two plates, and these two plates are conductors. So the conductor of capacitor basically they store charges, and these electrical charges basically uh, cause a creation of a potential difference between the plate of a capacitor. So we can write that the charge stored in a plate of a capacitor is directly proportional to the potential difference between the two plates. So we can open this equation as Q is equal to constant into V. V is a potential difference. So the unit of constant is basically is the constant is represented for a capacitor. Constant is represented by C, which is known as capacitance of a capacitor. The capacitance of a capacitor is a ratio of charge stored in a plate of a capacitor by a potential difference created between the plate of the capacitor. So we can define capacitance of a capacitor as capacitance of a capacitor is ability of a capacitor. It is the ability of a capacitor to store electric charges. The unit of capacitance of a capacitor is known as farad. And students, since you know that capacitance is a ratio of charge stored divided by a potential difference, so the unit of charge is coulomb, whereas unit of potential difference is volt. So the SI unit for a capacitance of a capacitor is coulomb per volt, and it is also written as farad. So the unit of capacitance of capacitor is farad. Students, there are different types of capacitor. The types of capacitors are based on the shape of the capacitor, such as the capacitors are present in a form of a spherical shape. These types of capacitors are known as spherical plate capacitors. Capacitors may be present in a form of circular shape. Their plates may be in a form of circular shapes. Such types of capacitors are known as circular plate capacitor. And most commonly capacitor used in electronic device is parallel plate capacitor. Capacitor may be present in a form of a cylindrical shape. So such types of capacitors are known as cylindrical plate capacitors. So now, dear student, in this lecture we will discuss about a parallel plate capacitors. We have already discussed in previous lectures about the spherical plate capacitors, and after this lecture we will discuss about the circular and cylindrical types or cylindrical plate capacitors. But this lecture is basically focused on parallel plate capacitors. The parallel plate capacitor is a type of capacitor which have two plates, and these plates are conducting plates placed parallel to each other. These plates store charge by application of electron potential across them. So we can basically define a parallel plate capacitor as parallel plate capacitors are capacitors having two metallic having two metallic conducting plates conducting plates placed at a very shorter distance d parallel to each other. So we can represent the parallel plate capacitor with a schematic diagram. Basically, these are two parallel plates. Suppose this is a parallel conducting plate S1 and S2. This is another conducting plate S2, and both these plates are basically placed parallel to each other. Due to this, the charges are stored in these parallel plates, and due to this, the position or the placement of the plates in a capacitor, these capacitors are known as parallel plate capacitors. Students, please keep in mind that the area of the plates of the parallel plate capacitor is always same. It is area vector for both the parallel plates of the parallel plate capacitors is same. So it is a property of parallel capacitor. First, the area of the parallel plate capacitor is same. Area of plates of capacitors is same. And second property of the parallel plate capacitor is that the spacing, the space or a distance between, which is we represent here with a d, the space between a parallel plate d is very small, is very small than the area of plate, area of plates. So d will be very small than the area of the plates, and due to this we can say that area d is appears as nearly area we can say that area a appear nearly infinite for the uh, for the space or distance or a distance between two parallel plates, because and this that is the reason if the distance between these two parallel plate is larger, then there will be efficiency of the capacitor will be decreased, because the electric field of lines cannot basically interact across these two plates, or the storage will be difficult. So in order to get an efficient capacitor, the distance between the two parallel plate is very small and it is nearly negligible to the area of the plates. Dear student, please keep in mind that electric field of lines. Suppose that in one plate there will be in parallel plate capacitor there will be a positive Q charge, and whereas when the charge is stored in them, and on the other plate there will be a negative Q charge. And you know that the electric field of line basically they electric field of line they basically move from positive charge toward a negative charge. These are schematic representative electric field of lines. They basically are directed from positive charge toward the negative charge. So in parallel plate capacitor, the electric field of lines, this is the third condition. In parallel plate capacitor, the electric field of lines are bounded from positive charge to negative charge of the plate. So dear student, please keep in mind that if the space D is less than area, then the capacitance of the capacitor will be more. So from here we can say that the capacitance of a capacitor depend on a distance between a parallel plate and as well as area of a parallel plate. This means that capacitance will be greater if the distance between the plate is less, which means that capacitance is inversely proportional to the distance between the parallel plate. Whereas if area of the plate is greater, the capacitance will be greater, which means that capacitance is directly proportional to the area of the parallel plate present in parallel plate capacitor. Now the student, important question here appear is that how parallel plate capacitor store charges. How is it possible for parallel plate to store charges? Since you know that parallel plate capacitor consists of two plates and these plates are placed parallel to each other. Suppose that this is plate S1. The area of the plates are in parallel plate capacitor is same. So the dimension of the parallel plates in parallel plate capacitor will be same. So this suppose that this is conducting S2 plate of the parallel plate capacitor. So in this situation, both the conducting plates are they have a no charge. In order to charge these parallel plates basically they are connected with a power source. Usually they are connected with a DC power source. Suppose this is a DC power source or DC battery, and with this these two parallel plates are connected. So now when these parallel plates are connected with a DC power source, these parallel plates act as a capacitor. Since the potential difference is created due to positive and negative terminal of the DC power source, and the role of a positive terminal is to pull electron toward itself, whereas negative terminal push electrons away from itself. So the electron will move from parallel plate S1 toward the positive terminal like this. So whenever electron move from positive terminal plate S1 toward the positive terminal, they will leave positive charge behind on the surface of the plate S1 like this. Since you know that charges reside on the surface of the conducting metal or plate, so whenever the charges electrons move from the surface, uh, uh, they will leave positive charge, and these positive charge will be present at the surface of the parallel plate capacitor. And whereas since you know that the negative terminal basically push electron away from itself, so electron will move like this from negative terminal of the battery toward the conducting plate S2. So this means that there will be a generation of negative charge on S2 plates. So dear student, keep in mind that on S1 plate there will be a shortage of electrons, whereas at S2 plate there will be excess of electrons. So now keep in mind that there will be two types of electric field present between S1 plate and S2 plate. One electric field will be from due to a positive charge, and it will be from positive to charge toward a negative charge. Since you know that electric field of line travel from positive charge toward negative charge, or they are from positive charge to negative charge, and let's say it as E1. So like this, uniform electric field of line from positive charge to negative charge will be like this. Now there will be another electric field, and that electric field will be generated by a negative charge. Since you know that the direction of electric field of lines are basically toward the negative charge, so these negative charge will have electric field of line, but they will be toward this the negative charge, and they will be like this, toward negative charge. And let's say we say these electric field of line, say it these electric field of line as E2. So the student, total electric field generated in a parallel plate capacitor will be E is equal to net electric field, E net, will be due to electric field generated by a positive charge plus electric field generated by a negative charge. So this is a net electric field present in a parallel plate capacitors. Now, dear student, as you know that whenever there is applied electric potential, this electric potential generate charges on the surface of the plates. And these charges which are present at the surface of parallel plate have a potential difference between them, and that potential difference depend on the number of charges stored at the surface of plate, which mean that the capacitance, the charges basically uh, are directly proportional to the potential difference. So the charges stored on a parallel plate are directly proportional to the potential difference present between the plates of the charges. So due to this, as you know that we can open this equation as Q is equal to C into V. C is a constant of proportionality, which is a capacitance of capacitance, and the capacitance of capacitance becomes C is equal to Q divided by V. It is a ratio of charge stored in a capacitance divided by a potential difference. Let's say it as equation number 1. Now, let us calculate the capacitance of a parallel plate capacitor. Since you know that in general the equation for capacitance is C is equal to Q divided by V, and as you know that potential difference V is equal to E into D, E dot D. Student, please keep in mind that suppose the distance between the two plates is D. Let's say distance between two plates is D. So the potential difference between these two plates will be E electric field, total electric field, into a distance between the two parallel plates. So we can rewrite this equation as potential difference is equal to, since you know that there are two types of electric field, E1 electric field due to a positive charge plus E2 electric field due to negative charge into DD, is which is a distance between the two parallel plates, and we say this as equation number 2. Now you know that the electric field for a electric field in a sheet, in an infinite sheet, is equal to E is equal to sigma divided by 2 epsilon naught, whereas the sigma is basically it is a surface charge density, which is basically charged divided by area. So charge on the plate divided by an area is a surface charge density. So basically we can suppose this is equation number 3. So basically we can incorporate the equation number 4 in equation number 3, and we can get that electric field intensity E is equal to, if we put the value of sigma, then electric field intensity will be Q divided by 2 epsilon naught into A. So we can say this as equation number 5. So now, since electric field intensity become E is equal to Q divided by 2 epsilon naught A for an infinite plane sheet, then as you know that there in parallel plate capacitor there are two sheets, so the net electric field of intensity is equal to E1 plus the electric field intensity due to a positive charge and E2. So then the net electric field of intensity become, if we put the value of electric field intensity in them, in suppose this is equation number 6, in equation number 6, then we get Q divided by 2 epsilon naught A plus Q divided by 2 epsilon naught A. So this equation will become E net is equal to 2Q divided by 2 epsilon naught into A. A2 will cancel with 2, and we can get net electric field of intensity as Q divided by epsilon naught into A. So this will be electric field of intensity between the two parallel plates of a parallel plate capacitor. And let's say that this is equation number 7. Now, dear student, let us calculate a capacitance of a parallel plate capacitor. Since you know that capacitance is equal to Q divided by V. V is a potential difference, and we know that a potential difference V is equal to electric field intensity between the plate of capacitor into D, the spacing between the plates of the capacitor. So V is equal to E into D. So we can put the value of V in the equation of capacitance, Q divided by E into D. Suppose that this is equation number 8. Now put equation 8 EQ7 in equation 8. We basically then we get that capacitance C is equal to Q divided by, what is the value of E? As you know that value of E is Q divided by epsilon naught A into D. Now, dear student, please keep in mind that Q will basically cancel with Q, and we get a capacitance of capacitor as C is equal to 1 over D divided by epsilon naught A. If we rearrange this equation, then we can easily get that capacitance of parallel plate capacitor is equal to epsilon naught A divided by D. This means that a capacitance of a capacitor depends on area of a area of plates, and and capacitance of capacitors depend on distance between the plates. So if the area of plate is more, if the area of plate is more, the capacitance value of capacitance will be more. And if a distance between two parallel plates d is more, then the capacitance will be less. This means that capacitance is directly proportional to the area of the plate and inversely proportional to the distance between the plates. Greater will be the distance, lesser will be the capacitance, and lesser will be the distance, greater will be the value of capacitance. Now, dear student, please keep in mind that for parallel plate capacitor, it is not necessary that the conducting plates are a rectangular shape. They can be of different shape. They can be a square. They can be circular. If they can be a circular, but the main, but the key important point to notice here is that the area of the plates of parallel plate must be same, and secondly, they must be placed parallel to each other. So if we have a circular parallel plate capacitor like this, suppose that this is a circular parallel plate. Let me redraw the circle because not completely pure circle. So if we have a circular parallel plate capacitor, suppose this is a circle S1, and this is a circle, suppose S2. Both the area of the circle is same, and suppose this r is a radius of a circle, and both the radius of the circular plate of the parallel plate capacitor are same, then and the distance between these two plates is, suppose it is x, then what will be the capacitance, what will be the value of capacitance of these circular parallel plate capacitor? How can you calculate the capacitance value for circular parallel plate capacitor? Since you know that as we have drawn the formula, capacitance for a parallel plate capacitor is equal to epsilon naught a divided by d. So now, as you know that the area of a circle is equal to pi r square. So pi r square. So we can basically incorporate the value of area in the equation of capacitance. Capacitance is equal to C into epsilon naught. In area, we will incorporate pi r square divided by, as you know, the distance between the plate is, between these two circular plates is x. So we will use x in equation. So this will be a capacitance for a parallel plate capacitor if the shape of the capacitor is in a circular form. So this is all about parallel plate capacitor. Parallel plate capacitor is a device which consists of two metallic parallel conducting plates, and these plates are placed in parallel plate capacitor in a very smaller distance. And the parallel plate capacitor can be of different shape. It could be circular and it could be rectangular, etc. But the main point to notice here is that the distance between them is very short and the parallel plates are parallel to each other, and the area of the parallel plate must be same to each other. So this is all about the parallel plate capacitors. Thank you for watching this lecture.